Welcome, grade 7 and 8, to Mr. Wensing's science class. This is going to be our new way of going through God's world, God's creation, when it comes to science, beginning in particular with mixtures and solutions and seeing where this takes us. So, when we think of the way that God maintains and upholds the world, we often think of sunlight and water, the plants we use for food, or the seasons that provide for crop growth. But the way substances interact with each other is just as important for supporting life. One way that matter interacts is by forming solutions. You may think of a solution as being liquids, and in fact, many solutions are liquids. However, solutions may also be gases, such as air, or solids, such as steel. In today's video, we're going to find out about different types of solutions and how the substances in solutions can react with each other. Picture this. It's a hot summer day and you're thirsty. You can go to the kitchen and you want to make some lemonade from a powdered mix. After dumping just the right amount of powder into the water, you stir until all of the powder has dissolved. Then you pour a glass of lemonade. Later, you can pour another glass of lemonade without having to stir the lemonade again. Why hasn't the lemonade powder fallen to the bottom of the container, though? The reason you don't have to stir the lemonade again is because the lemonade is now a solution. A solution is the homogeneous mixture of two or more substances. The particles in a solution are evenly distributed, so all of the parts are identical. When two substances are mixed together to form a solution, one is dissolved into the other. The substance in a solution that is present in the largest amount and acts as the dissolving agent is called the solvent. The substance in a solution that is dissolved is called the solute. The solvent dissolves the solute. When you add lemonade powder to water, the lemonade powder is the solute and the water is the solvent. The solute particles of a solution are too small to be seen. They're the size of ions or molecules. That's why you can't see the sugar particles dissolved in the lemonade. These particles will stay dissolved in the lemonade indefinitely, so you won't have to stir it again later on. If a liquid solution is poured through a filter, both the solvent and solute will pass through without leaving any residue. Not all solutions, though, form at equal rates. There are three things we're going to take a look at that determine how fast a solid solute will dissolve into a solvent to form a solution. The first of these is temperature. Solute crystals dissolve more quickly in warmer solvent than in colder solvent. The added energy of the heat makes the molecules move faster, creating more frequent collisions between solute and solvent molecules. The solvent particles dissolve the solute particles more rapidly. It's one of the reasons why tea works faster in bringing all the particles through the entire cup when it's much warmer. Second, we have surface area. The greater the surface area, the faster the solute will dissolve. Smaller crystals of solute will dissolve more rapidly than larger crystals because there's more surface area. Have you ever added a sugar cube instead of sugar granules to a hot drink? If so, you might see or know that it takes much longer for the cube to dissolve. The sugar cube has less surface area from which the hot drink can pull away different particles. Third, we have movement. When the solvent is shaken or stirred, solute particles are moved around, bringing fresh solvent particles into contact with the solute particles and making the solute dissolve faster. Have you ever used Italian salad dressing made from oil and vinegar? You have to shake and quickly pour the dressing on your salad before the oil and vinegar separate. Oil and vinegar will not form a solution because solvents and solutes are restricted by the like dissolves like rule. And there are two basic types of substances. We have polar and nonpolar substances. A polar substance is a substance that has molecules whose electric charge are unequally distributed. So, opposite sides of the molecules have opposite charges. Water is an example of a polar substance. Many acids are also polar. Polar solvents dissolve polar substances. The slight charges on a water molecule attract the charged particles of the salt. A nonpolar substance is a substance that has molecules whose electric charges are equally distributed. Oils are nonpolar solvents and will dissolve other nonpolar solvents or substances such as gasoline or grease. Ethanol is a substance that actually has both polar and nonpolar properties, and so because of that, it will actually dissolve both polar and nonpolar substances.